All right, guys, in the second section of chapter 4, we're going to be starting to solve quadratic equations. So we did the same thing when we were solving linear equations. There's a bunch of different methods that we're going to be able to use, and one of them is going to be to solve by graphing. So we learned how to make the graph. Now we're going to be actually solving these quadratic equations by using that graph of the parabola that we just learned how to make. So what it means, first of all, to actually solve a quadratic equation, I'm going to draw you guys a little picture. So solving quadratic equations, it would be something like this. You'd have ax squared plus bx plus c is equal to 0. So notice that is different from a function. A function is like f of x equals or y equals. So this is just one variable, and it's set equal to 0 rather than being set equal to y. So that is actually a really important distinction to make note of. So when we're actually solving them, important note here is that zeros of the function are the x-intercepts of its graph. So remember, this used to be y equals this function, or f of x equals this function. So to find x-intercepts, remember from previous chapters, what we would do is replace the y with a 0. So this is like replacing the y with a 0 and looking for x-intercepts. So here's what that looks like graphically. If we had a graph, and it looked something like this. These points right here, the x-intercepts, those would be the solutions of the equation. Okay, so right there, right there. If you can figure out what those values are, that's what it means to solve the equation. So this right here and this right here, those are the solutions. Okay, so that's the general idea that we're going for. I'm going to go through a couple specific examples, and that's going to help us to figure out how we're going to solve some of these different equations. So first example, we've got x squared plus 6x plus 8 equals 0. So we're going to solve it by graphing, but we need to actually be able to get way more specific than we were in the previous section. So I'm going to show you guys how we're going to use our calculators in order to plot even more points than just the 3 that we plotted before. Okay, so we're going to graph this, and we're going to graph it the same way we did in section 4.1. So we're going to start by finding the axis of symmetry. So remember, that's x equals negative b over 2a. So that's negative 6 over 2 times 1. So that's negative 3. All right, so let's go and graph that. So we're at negative 3, and that's going to be our axis of symmetry. And then remember, the vertex will fall somewhere on that line. So for the vertex, we're going to plug negative 3 into the equation. Okay, so this is 9 minus 18 plus 8. So the positive numbers are 17, minus 18 would be negative 1. So we know that our vertex is going to be right here at negative 1. Okay, and then we can go from there. So our y-intercept is the last thing that we find, and that's at 8. Remember, it's always just the constant. So if I plug in 0, I get 8. Going to go up into this graph a little bit. All right, and then our mirror image would be up here. So 3 more units over, and then over at that point. So connect the dots, and it would look something like that. All right, so we're looking for the x-intercepts. So you can see a point right here and a point right here. It looks like just about negative 2 and negative 4, but we can't be sure. So what we're going to do, just to confirm that, is we're going to look at a calculator table. So I'm going to show you what this would look like. So what you're going to do is you're going to open up a graph, and then we're going to type in our function. So we'll have x squared plus 6x plus 8, and we're going to graph that. Okay, so that's exactly what our graph looks like. And then we're going to open a table. So hit Control first, and then T for table, and we can look at some of these points over here. So if you click back, so that's what we're looking for. See this right here? How we actually are exactly at 0 at -4 and then 0 at -2. So that means it actually is hitting exactly at 0 right there and right there. So when it comes out to give us 0, that means that's a solution to our equation. Okay, so if we go back here, that actually is hitting right at -4 and right at -2. So our solutions are x equals -4 and x equals -2. Okay, so with this one, this quadratic, I had 2 solutions. There are actually other possible outcomes, so we're going to go through these 3 possible outcomes. Possibility number 1 is basically what we just had, that there are 2 solutions, so our equation would look something like this. It would cross through once, turn around, come back and cross through again. So this is a 2-solution outcome. There's another possibility where we could have just 1 solution, and 1 solution would happen like this, where it's coming down and the point where it turns around is right where it's sitting on the x-axis. So it just like bounces off, has 1 solution right there, and then it turns back around. So there's the 1 solution scenario, and then 0 solutions would be something like this, where it doesn't actually go low enough to hit the x-axis. So that would be 0 solutions. And then keep in mind that any of these things could occur as well if your graph is upside down. So, you could have an upside down graph with 2 solutions, you could have an upside down graph with 1 solution, or you could have an upside down graph with 0 solutions. So I'm not trying to be partial to the right side up ones, that's just what I happen to do. So they could be right side up or upside down. Okay, let's look at this one. We're going to solve this one by graphing, so we're going to basically walk ourselves through the same process that we just did with example 1. So first thing, this is not solved for 0 yet, so you want to add that 4 over to the other side. So it is x squared minus 4x plus 4 equals 0. We don't want to begin to graph this until you have just a 0 on the other side. So that might pop up. So first start with the axis of symmetry. And the axis of symmetry, we use the formula x equals -b over 2a. So negative b would be a -4, so -4 comes back positive, and then over 2 times 1. So over 2, 4 divided by 2 is 2. So start by graphing that. Okay, and then we are going to plot our graph, our vertex. So we plug the 2 into this equation. So 2 squared minus 4 times 2, and then plus 4. So clean this up a little bit. 2 squared minus 4 times 2 plus 4. So 4 plus 4 is 8, minus 8 comes out to be 0. So the vertex, if I plugged in 2, it gave me 0. So this point right there is my vertex. Okay, last step for graphing is to find the y-intercepts. And make sure you're looking at it in this form. It's very important that it's actually in the right form. So that makes this number right here our y-intercept. So if you plug in 0, 0 minus 0 plus 4 leaves you with 4. Okay, so I go up 1, 2, 3, 4. There's 1 point there. And then the last step before you actually graph it is to get a mirror image. So I'm 2 units away here. So I'm going to go 2 more units, plot a mirror image, and then connect the dots. So this one is one of those cases where I have 1 solution. So the only solution that I have is right at x equals 2. That's the only x-intercept. So x equals 2 would be your solution. Okay, so these 2 examples that I just saw, they came out at nice, neat numbers. Remember I mentioned with this one, like, hey, it looks like it's crossing through right at -4 and -2, but it might not be. It's also possible that you could be crossing through at these crazy decimal values. So in the next little section, we're going to go through and talk about how you could estimate your solutions. So you're not going to be dead on, but you can always estimate, and you do that by saying which integers between which the roots are located. So for example, you might say like, oh, it's between 3 and 4. And we don't need to get any more accurate than that right now. We're going to get there later in the chapter, but just saying what it's close to will be plenty for now. So let's take a look at these examples. So we're going to solve this one by graphing. And if exact roots can't be found, then we're going to state the consecutive integers between which the roots are located. So let's set this up. So we're going to start with the axis of symmetry. This process is going the exact same way for all of these problems. X equals -b over 2a. So -4 over 2 times negative 1. So that's a negative 2. So that comes out to be positive 2. So let's plot that. And the vertex, for the vertex I plug in 2 into this equation right here. So negative 2 squared plus 4 times 2 minus 1. So careful with this, negative on the outside means that the 2 squared actually becomes negative. So that becomes negative 4 plus 4 times 2 minus 1. So these are a negative 5 and a positive 8. So that leaves you with 3. So that's an ordered pair. When I plug in 2, I get 3. So plot a point right there. And then next, I am going to do my y-intercepts. So the y-intercept is always just the constant hanging out on the end. If I plug in 0 for x, 0 plus 0 minus 1 would be negative 1. Okay, so that would be this point right there. Okay, and finally, plot your mirror image. That would be right here. And then we can connect the dots. Okay, so taking a look at the graph, it's not hitting like right at a whole number. You can see it's hitting right around here, it's hitting right around here. So you would just say what 2 whole numbers that falls in between. So this is between x equals 0 and x equals 1. So you could say x is between 0 and 1. And then here this looks like between x equals 3 and x equals 4. Okay, so that's your final answer. If it doesn't fall right on a whole number, you can just estimate, just like I did there. Okay, let's do one more. This one, start with the axis of symmetry. X equals negative b over 2a is our formula. So negative b here is 5 over 2 times 1. That's just a 2. So this is going to be kind of an ugly one. So we end up with negative 5 over 2, which is negative 2.5. So let's go ahead and plot that. 1, 2, 3. So that's 3. So 2.5 would be just right down the middle there between negative 2 and negative 3. And then my vertex, just like every other problem, you just plug that in. So plug negative 2.5 into this formula right here. So negative 2.5 squared plus 5 times negative 2.5 and then minus 7. All right, so this is going to take a little bit of work. So negative 2.5, if I square that, then I end up with 6.25 plus, and then 5 times negative 2.5 would be negative 12.5, and then minus 7. Okay, so this is something that you would probably want to break out a calculator for, and that's totally fine. So these two together, that would be a negative 19.5. And then if I combine with this one right here, and that is going to leave me, sorry, I lost track of my thoughts there. That is going to leave you with a negative 13.25. Okay, so that's your vertex for that particular example. All right, so let's plot that. We're gonna have to scale this graph a little bit. So let's call this negative 3. So 3, 6, 9, 12, 15. So negative 13.25 would be around there. This is just estimating based on the fact that I'm scaling by 3. All right, and then I am going to mark my y-intercept on there. My y-intercept is a negative 7, always just the constant on the ends. Actually, sorry, let me write that as an ordered pair. 0, negative 7. So here's negative 3, negative 6. So estimate right around there is negative 7. So now this is 2.5 units away. So let's go another 2.5 units, and we can mirror this point right here. Okay, so we're kind of getting ourselves into trouble here. You can see that it looks like this is not going to be super accurate. So like 6 might be right here. So like, is it between 5 and 6 on the negatives? Is it between negative 6 and negative 7? And then over here, you know, is that between 1 and 2? Might be. So I'm going to show you guys just one extra little trick that we can use, and I'm going to take you back to the calculator. So let me change out this function that we had. Okay, so I'm going to go back over here into the graph, change out the function. So I'm going to delete the one that we had before, and now I'm going to type in this new one. This new equation is x squared plus 5x minus 7. Okay, so now we can get a slightly more accurate picture. So I want to show you over here on the table. So take a look. Here we're at -7, and it's up at 7. And then at -6, it dips down to -1. So it's happening somewhere in here. So we want it to equal 0. So 0 is somewhere in this range right here. So the first one is going to happen between -7 and -6. And then if we keep scrolling, it's like all these numbers are negative. Okay, and then it happens again right here. So here it's a negative number, and here it's a positive number. So the crossing through must have happened somewhere in there. So that's also between 1 and 2. Okay, so we'll go through that in more detail in class, but you can use your calculator to do that. So x is between -7 and -6, and we also found another one between 1 and 2.